Hello everybody and welcome to the second Chemcraft modding update. In this episode I've added a lot of features I think, and guess what? I finally got a partner. His name is Quest Wizard and he has help with textures and programming, and it's just been amazing. He's a really cool guy. In case you don't know what Chemcraft is, it's a Minecraft mod that I'm developing that aims to add in-world chemical and physical reactions to Minecraft. So you'll be able to like throw down, I don't know, some gold onto an iron plate and melt it with some flame under it, for example. To recap last episode, the only things that were added were the elements with some data, as well as some pretty basic compounds and ores. This time around, however, we have polished the elements a lot more and added isotopes, so radioactive isotopes on all elements, which I'll show you in a second. Also, we've added some basic compounds, but we're still working on compounds. Okay, first thing I want to do is go to the elements tab. Now, you might have noticed right away that there's been some new textures. And yes, Quest Wizard has made some very beautiful textures, and I'll explain why they're mostly cubes in a second. Now, if I hover over the elements, however, you'll see you get more options now. At the top you have the isotopes, and at the bottom you have quantity. Right now, let's focus on the isotopes. The isotopes, as you can see, it says control plus scroll to choose isotope, and if I hold on control, I can scroll with my mouse to select whatever isotope I want. And this shows you its half-life, abundance, if it's not radioactive mostly, and what it decays into. If it's green, it means it's radioactive, but it has a fairly decent half-life. If it's red, it means it has a half-life of, I believe, less than a minute, or less than an hour, I'm not sure which one. And as you can see, we can go to any compound, and it will also, if you hold on control, it will show us its average isotope composition in the world. So the carbon you'll find on Earth is usually mostly 98.9% carbon-12 and 1% carbon-13. You can do the same thing for nitrogen, just see that it's like 99.6% nitrogen-14 and 0.3% nitrogen-15. And once again, we can scroll through the available isotopes. So I think this is very cool. And if I were to take this out, I can no longer scroll. It'll just show me the information as I hold on control. I've also polished a little bit the information on the elements. I've added the electron configuration, but that's about it. Now I want to draw your attention to the quantity. So I have not added a tooltip for this yet, so it does not say hold shift and scroll to select the option, or like whatever, like select whatever you want to change. But if I hold down shift and scroll down, I can go to quantity. Now I can hold on control on quantity, and I can use my mouse or hold down alt while doing this to select the amount of moles. Now if I were to just leave it at default and take a chunk of vanadium, for example, I would get this. As you can see, it's a cube. It should be differently sized, but I'm still working on that. The reason I made these cubes is because it's very simple to get its size based off its density when it's a cube. Now, if I were to throw down this vanadium sample on the ground, you'd be kind of surprised. It's super tiny, because that's actually what 1 mole of vanadium would look like. This actually surprised me a lot as well, that so much vanadium, because this doesn't seem like a lot, but this is 50 grams, is this tiny. I mean, look at that. You can barely even see it. Look at that. That is tiny. Now, if I want a bigger chunk of vanadium for, whatever reason, probably, to actually use it, I can go get a vanadium, which is, I'm sorry, somewhere right here. There we go, vanadium. I can, once again, hold on control, and I'll use alt, and then I can select whatever amount I want. So let's do 4.6 thousand moles, and then let's go back down, just to show you the comparison, to around, let's say 181 moles. So, once again, the sizes in your inventory don't change. I will fix this. As you can see, they're the same. But if I check this down, this is the big sample. That is the 4.6 thousand moles, I believe, and this is the a couple hundred moles sample. As you can see, the sizes differ. This is surprising once again, because look at this. It looks tiny, but it actually weighs. Wow, 234 kilograms. Yeah, this is just crazy to me. I don't know who else is fascinated by who else might be fascinated by this, but to me this is just crazy. Look how tiny it is. Let us also not forget that Steve is quite literally the size of an IKEA closet. I'm not joking. So, as you can see, now we have every single element. Last time we didn't have every single element, but Quest Wizard, he grinded and like got out a bunch of these elements. As you can see, they look similar, but they're just I think they look really good. Some of them look pretty similar, but you know, a lot of metals look similar, and we want to keep this as realistic as possible. We could use different tints based on their oxides, but this is pure elements, just for anyone wondering. These are the purest form of elements you'll find, so these cubes. So this is in case you're doing a reaction where it requires just a pure element, you can take it out of the inventory. It will of course start harnishing and oxidizing after you take it out, depending on its reactivity of course. But in the inventory, it's as pure as it can be, so that's why they look very similar. Now, we do have some heavy elements. The elements with the question marks, you might have noticed, they don't have, like, we don't know what they are, like how they look like, because they are radioactive. As you can see, actinium, for example, it's mostly has radioactive samples. Like maybe there's one with this 21 years of half-life, but that's still not a lot. Once again, astatine, polonium, you know, elements like this, we don't really know what they look like, although we might have made some errors because we might know what they look like, but it's pretty hard to get an image of them online, so I apologize if we made an error somewhere. And obviously, you know, the super heavy elements like organocin that you're not going to find much here, but there is, like, you know, this one, what do you call it? Isotope. As you can see, it says spontaneous fission. For spontaneous fission, we will go back to it right now. Right now, as you can see, it just says itself. It goes into itself. Well, in reality, it will, you know, churn into two different nuclei and release neutrons like a fission reaction would normally do. However, you need to, how can I say this, guess what the products are. So we're still going to work on that. I will touch on that later. So yes, so far, that's what we have. Now, I want to talk about the compounds. The compounds, we're still working on this. Actually, matter of fact, as I'm recording this today we had, like, Quest Wizard, really, once again, thank you a lot for all his help. I mean, he's an amazing partner, and he has helped me to scrape compounds. That's how we're doing it. We're going to get them online because my original idea of generating them and calculating their properties, well, kind of knew from the start that it was going to be really difficult, if not impossible. So, I want to show you the compounds right now, what we have so far. As of today, once again, Quest Wizard helped a lot, and we got some compounds in. They might be a little bit buggy, they might not look the best, but bear with me. Alright, now I'm going to go to the compounds. Now, you might say that they all look the same, and most of them don't, but this is just a placeholder texture. This is pretty self-explanatory. The water droplet is a liquid, the powder is a solid, and the gas is, of course, well, gas. So, you might be seeing, like, weak acid, strong, like, weak base. That is, once again, I'm still working on this, on its, how can I say, acidic properties and whatnot, so it is not accurate, mostly. But, as you can see, there is information here. This is in Celsius, because I'm also working on the features that allows you to select, well, how can I say, whatever temperature unit you want to work on with, as well as in the future, this will be super customizable, this mod, since it overhauls so much things. Some people might not like the things it overhauls. You will be able to customize different things. You'll have presets and, you know, etc. So, I'm just working on this, that's why it's in Celsius. As you can see right now, we're in Celsius. There's a couple interesting things, like, I'm pretty sure, yeah, so, I'm not sure, how this happened, but there's these, how can I say, interesting compounds here, who made it through, but you can see there's a lot of, compounds you'll find, and I think the information here is pretty accurate. Don't mind this, like, trailing decimals on this Celsius. I don't know why it does that. It's just converting from Kelvin to Celsius, so I don't know why it has so much decimals, but you know. The boiling point, 82 degrees Celsius, melting point, -27. 127, which I'll put on screen if that's accurate. Okay, and you'll see we have like stuff like ozone, we have hydrogen bromide, pretty sure, yeah, that's a gas. Carbon monoxide, you know, it's a gas. Sulfur dioxide, it's a gas. Obviously, ozone, yeah, methane. So yeah, we have a lot of these things here, and I think it's pretty cool. I really like this so far. It has a mix of both organic, inorganic, and, you know, salts. That will be fixed, I think. Yeah, we'll fix that. We'll sort them out between different, you know, tabs. I have disabled the other tabs you can see here. The alloys are still not working, by the way, in case anybody's wondering. We'll work on those later. We'll actually get data online on what the alloys are made of, not just like, you know, matching them together or whatever, because that, I don't think, is that great. A couple side notes here. I did overhaul some of the items right now. This is just features that I'm still working on. For example, this item, for example, if I just chuck something down, it will be 3D. It won't like start, you know, moving around. So that's really helpful, especially when you have something like, you know, like, let's say take a, oh, it's tiny, but you get what I mean. Like, it will be just a cube on the ground, and that's very helpful because let me just quickly get something with how can I say, a lot of moles. Okay, sorry. Yes, quantity, and then let's get this, get quite a bit, just so you can actually see it. Oh, well, I guess there we go. So, for example, you'll be able to later in the mod, which also, in case you haven't noticed before I say this, you have to shift to pick items up now. Like, you can just, like, go over them. I'll add item physics as well, so you can, like, you know, play curling with, like, plutonium and beryllium or so. So, I mean, yeah, I guess that's what I get for, changing a lot of different values, a lot of different item values, and, you know, data really quickly. But, I mean, that's just how modding is. So, yeah. Also, don't mind the grass. I'm just working with tints for other things as well for the future. Anyways, as I was saying, I'll be able to, like, for example... Oh, crap. Whoops. Okay, that's probably not a good idea to have that. So, yeah, and then you'll have some sort of this kind of configuration. The reason I'm making it so they are not bobbing around and whatnot is I want to give them physics, like I said. And you'll be able to, like, come up to this, place this down, and it'll melt, it'll turn into a liquid, and it'll solidify, obviously, when it gets to the ground, somewhat colder. Which is going to be done through, you know, the data in the different elements and compounds, so it'll be fun. You'll be able to throw, like, sodium down, or, like, sodium hydroxide, or, like, sodium chloride down into different, you know, hot areas, and it will melt, obviously, and you'll be able to, like, you know, melt sodium hydroxide, like, electrolyze it. It's going to be really fun, I think. So, yeah, this is the update I have right now. For anybody who's wondering how uranium looks like, because I bet there's some people who are wondering about uranium, because I'll probably have it in the thumbnail. I can select through different isotopes, which don't do anything right now, by the way. And you can see the average isotope composition of uranium right there. So yeah, it's pretty cool, I think. So let's get like a chunk of uranium to end off the video. For example, here we go. 7.7 thousand uranium moles of uranium, and there we go. As you can see, looks very good. It's on the ground. And for gases, before I leave, I just want to show you what the gases look like as well. Let's get some oxygen, for example. Oh crap, sorry. Let's get like 131 moles of oxygen. It does not have a texture, but it will use the ideal gas law to figure out the volume of it, you know, at 1 atmosphere of pressure. So this was the second modding update of Chemcraft. I hope you guys enjoyed. We're going to continue working on it. In case anybody's wondering about helping, you can always join the Discord server and ask me. In terms of texture artists, I think we already have a good texture artist right now, which is Quest Wizard, who also helps me with some other stuff as well. I would ask if you're interested in helping and you have chemistry knowledge. That would be very useful, especially like, you know, higher level chem that we might not know. That could be very useful for us to, you know, do calculations and to, you know, make reactions happen, you know, calculate products and stuff. Yeah, I don't know. You get that point. You get the idea. Thank you guys so much for watching. As of today, Merry Christmas to everyone watching, and have a good day. Thank you so much for watching. If you could like and subscribe, would help the channel a lot. You know, as always, like everybody says, you don't have to. So yeah, if you like the video, like it. If you dislike it, the dislike button, I guess. And I guess let me know in the comments what you disliked about it. You can join the Discord in the description at any time. And yeah, I'm gonna stop talking and let you go watch another video or do something else. Thanks for watching. Bye bye.